Hello students, welcome to AriserTalent. I am your math teacher Arpita Sharma. Okay, so in the previous lecture we have discussed about polynomial and this is the very chapter we are learning, chapter number 2, polynomial, right? So we have discussed the degree of polynomial, okay, monomial, binomial, trinomial, right, quadratic polynomial, linear polynomial, cubic polynomial, and we were discussing graphs. Okay, so we have taken a linear polynomial and its graph, and it was in the form of this. This was our x-axis, this was our y-axis, and the graph was something like this. That was linear. Okay. Then talking about quadratic polynomial, we were having a graph like this. Okay, talking about cubic polynomial, we were having a graph like this. Okay, so it was cutting it at 3 places, at 2 places, and at 1 place. 1 place in case of linear polynomial, 2 places in the place of quadratic polynomial, and 3 case in case of cubic polynomial, right? Now we have taken this example for linear, this for quadratic, and this for cubic. Okay, now we used this graph and plotted this, and this as per the equations, and as we got the value of y's, and we discussed zeros of polynomial. Okay, now look at this and these 3. Okay, if you compare, you can easily find out, you can easily see that these graphs are basically these graph, and this is nothing but linear polynomial graph. This is graph for quadratic polynomial, right? And this one for cubic polynomial. So the highest degree in this was 1, in this was 2, in this was 3, and we can conclude by this that the maximum number of zeros in linear will be 1 as the degree is 1, in quadratic will be 2 as the degree is 2, and in cubic will be 3 as the degree is also 3. Okay, at most. So there are some cases. The graph ypx are given in figure below. For a polynomial px, find the number of zeros of px in each find the number of zeros of px in each case. Now we can easily identify, in this case it will be 1, in this case it will be 2, in this case it will be 3. I have told you this kind of question in my very first lecture, in my very first lecture, but we haven't known the reason behind this. Now we know this. Okay. Moving forwards, when I talk about this one, the quadratic one, these are the possible cases for quadratic polynomial. Okay, so this is our x-x axis and this is our xy axis. The graph can be like this. Okay, that is downwards, parabolic but downwards, and crossing 2 points on x axis. This condition can be for upward too. Now the next one, what if this point only touches one point? This is of quadratic polynomial. This graph is from quadratic polynomial, but it's touching only one point. So it is quadratic polynomial, but it will not have two zeros of polynomial. So it will have only 1 zeros of polynomial. It was having 2 zeros of polynomial. It will also be having 2 zeros of polynomial. And this, okay, I'll draw it again. This is again having 1 degree of polynomial, right? Now, we can have one more case. What if the parabola do not touch the x axis at all, like this? It can be above or below the x axis. Okay, so in this case, where it's above zeros of polynomial is what? Zero. We are having no any zeros of polynomial in here in this case, and also here in this case, zeros of polynomial. That means no any polynomials of 0. We cannot have ax plus b y equals to ax square plus say b. Okay, we cannot have this as 0 for any value of x. Okay, understood this one? Now, possible cases for cubic polynomial. Correct it, it's cubic. For cubic polynomial graph, the first one we have discussed earlier. Okay, we have drawn this kind of graph. In this case, 1, 2 and 3 degrees of polynomial we were having. Now, in this case, we are having only one case. Even its highest degree is 3. In this case, we are having 1 and 2 zeros of polynomial. So here we are having 3 zeros of polynomial. In this case, we are having only 1 zeros of polynomial, and in this case we were having 2 zeros of polynomial. Okay, note it. Right, I am going to rub this now. So now you have seen that the zeros of a polynomial can be at most, if it's linear, it can be at most 1. If it's quadratic, it can be at most 2. That means it can be 1, it can be 0 also. In case of cubic, it can be either 3 or 2 or 1. Okay. Okay students, so we can conclude that if degree of polynomial is 1, it will be having linear so we can conclude that for linear polynomial, okay, zeros of polynomial may be 1 for quadratic polynomial, zeros of polynomial may be either 0, okay, 1 or 2. So we can write it at most two and 4 cubic polynomial. It can be at most, say what? Right, 3. Okay. So we can conclude this. Now, note this, I am going to rub this part. Okay. Let's now discuss about relationship between zeros and coefficient of a polynomial. Zeros and coefficient of polynomial. Now, this graph is of no use for us for this particular slide. Okay. So, zeros and coefficient of polynomial. What is the relation here? Let us now consider one equation 2x square minus 8x plus 6. We are considering an equation 2x square minus 8x plus 6. Now, remember in 9th class how we used to bifurcate this term somehow that multiplication of these two, 6 2s are 12, 12x square will be used here. Now, let me tell you, this can be rewrite as two x square minus, here we are taking polynomial of x, 2x square minus 8x plus 6. Now, what we have done, we have written 8x minus 6x plus 2x. Now, you can write 8x as 7x minus 7x and minus x also. You can write 8x minus 8x as minus 5x minus 3x also. So, why we only used to write like this minus 6x and minus 2x? When you look carefully, you will find out. Okay, 2x square multiplied by 6 when we will do this, this will become 12x square. Now, multiply minus 6 and minus 2x. What are you getting now? Again, that will be plus of 12x square. So, you will divide this and this number, you will divide this number in such a way that addition or subtraction of this number will be like such that coefficient of these will be having the multiplier coefficient of this. That means the multiplication of these terms will be equal to multiplication of these two terms. Now we can see that minus 6x minus 2x multiplication is plus 12x square, which is equal to multiplication of 2x square and 6. Okay. So, how can we again solve this? Implies that polynomial of x, how can we solve it? 2x is common here, also here. So, can I take out 2x here? If I take out 2x here, I am taking 2x common here. So, what is left over here? X minus 3. Is that so? Now, I have to take something common from these two terms like this, that I will get x minus 3 in bracket. So, see this carefully, look this, and you will find you will be taking minus 2 as common. So, now you will get x from here and minus is plus. So, you will get minus 3 here. Now, x minus 3 in this term and x minus 3 in this term too. So, how can you rewrite it? Polynomial of x equals to 2x minus 2, because I am taking x minus 3 common. Okay. Okay, students. So, what will you get? You will get 2x minus 2 multiplied by x minus 3. Okay, now to get zeros of polynomial, what you have to do? We will get zeros of polynomial of this equation if px is equals to what? 0. Okay. Now, we will write for polynomial pardon me, for zeros of polynomial px will be equals to nothing but 0. Okay. Come here in this part. So, in this case 2x minus 2 can be 0. Okay. Or x minus 3 can be 0. So, if 2x minus 2 is 0, then this implies what? 2x will be equals to 2, and this implies that x equals to 1. Okay. So, x equals to 1 is the zeros of polynomial, and by taking x minus 3 equals to 0, what you will be having? X equals to 3. So, again Now what you conclude? That for px 2x square minus 8x plus 6 for this polynomial of x equals to 1 and x equals to 3 are what? Polynomials of 0. Okay. So, for polynomial of x, 1 and 3 are zeros of polynomial. Okay, note it down. I am going to rub this. Okay, so I am rubbing this part, but eventually I am going to keep this particular equation, particular polynomial here, because we were discussing zeros and coefficients of polynomial relationship. What is the relationship between zeros and coefficient of polynomial? So we will discuss it with the example of, with the help of this example. Now, look here, zeros of polynomial are 1 and 3. Now do what? Add these two, 1 plus 3, that will be equals to 4. Now multiply these two, 1 multiplied by 3, that will be equals to 3. Okay, now you can rewrite this as minus of minus 8 by 2. Can you do this? Minus of minus 8 by 2 is, this will be minus 4 by 2. Okay, sorry, this will be minus 4, and minus 4 multiplied by minus will be again what? 4. So it's 4 again. Now, how can you rewrite 3? You can rewrite it like 6 divided by 2. Now look at the numbers carefully. Minus 8. Can you relate this from this equation? Yes, the coefficient of x in this polynomial is nothing but minus 8. 2 is the coefficient of x square. 6 is the coefficient, no, it's not a coefficient, it's a constant term in this particular polynomial. You can also say this the coefficient of x to the power 0. So basically it's the constant term. Constant term divided by 2. 2 is what? Again coefficient of x square. Now if I am going to add the polynomial, then addition of polynomial equals to minus of coefficient of x divided by coefficient of x square. Coefficient of x square, right? Now look at this term, multiplication of made it zeros of polynomial. Addition of zeros of polynomial. Okay, multiplication of zeros of polynomial. That will be equals to, see here, look here, 6 is what? Constant term. Divided by what? Coefficient of, say, coefficient of x square, right? Now, I am rubbing this, okay? Now, this is the form a x square minus, because we are going to generalize this. So, it is in the form of ax square plus bx plus c. Okay. Now, this polynomial of x, let zeros of polynomial are what? Alpha and beta. Alpha and betas are what? Zeros of polynomial. So, by this what will you get? Alpha plus beta. Alpha plus beta minus of coefficient of x. Okay. That is b by a, and multiplication, that is alpha multiplied by beta Okay, this will be what? This is C. So, C by A. So, this is the relationship between zeros of polynomial and coefficient of a polynomial. Okay, students? Okay, so we have covered the maximum theory part here, right? In the next lecture, we will be talking about some examples, some numericals, that will also include your exercise. We will do that in the same form we will write in our board exams, because it's very important, students, to prepare yourself for board exams, right? Okay, till then, keep watching. Thank you.